Okay, today we're going to dive into something that is, well, it's pretty wild. We're looking at a possible connection between a 2,000-year-old philosophical text from India and, get this, the very foundations of modern physics. The parallels here are absolutely stunning, and they really make you rethink the history of ideas. Let's get into it.
So where do we even begin? Our journey starts by looking for clues about our physical world, but we're looking in a very, very old place, an ancient school of Indian philosophy. And this is really the heart of the whole explainer. Could an ancient text actually describe reality in a way that lines up with modern physics? Now, we're not talking about them writing down E equals mc squared or anything like that. We're talking about the fundamental nature of things. The text we're looking at comes from the Vaisheshika school, which was one of the earliest, most detailed philosophies of realism in India.
All right, our investigation kicks off with a question that sounds super simple but is actually incredibly deep. What even is an action? What is motion? Is it a thing all by itself, or is it something else? Well, the Vaisheshika school had a very specific and very cool idea about this. They captured their whole idea in this one kind of cryptic line. It introduces this key concept, Karmatva, and says that this quality exists because of actions. So what on earth does that actually mean? What they're saying is, when a ball is flying through the air, there isn't the ball and some other invisible thing called motion that's attached to it. No, these ancient thinkers argued that this action-ness, this karma-tattva, is just an inherent property of the action itself. It can't exist on its own. Okay, so we've got this ancient philosophical idea of action-ness. Pretty interesting, right? But how in the world does that connect to modern physics? Well, the first parallel is surprisingly direct, and it has to do with one of the most basic concepts in science, momentum. And here it is, the first big aha moment. On the left, the ancient idea. Karmatva only exists when something is actually doing something, when it's an action. On the right, modern physics. An object's momentum only exists when it has velocity. If it's standing still, its momentum is zero. Do you see the parallel? Both systems, thousands of years apart, figured out that action isn't some separate ghost in the machine. It's just a state of being for an object.
And of course, you know physics, it loves to put a number on things. The famous equation for momentum, P equals m times v, gives us a precise mathematical value for this quantity of motion. You can almost think of it as the formula for Karmatva.
Let's just let that sink in for a second. Both of these systems, separated by 2 millennia and totally different methods, concluded that you don't need to invent some extra invisible motion stuff to explain things. Motion is just an emergent property of mass that's, well, moving. That's a huge convergence of thought. But if you thought that was cool, hold on, because the connection is about to get way deeper, and frankly, a lot weirder. Let's look at the very next line in the text, which is going to take us out of the classical world and into something that feels surprisingly quantum. This next line is even more of a head-scratcher at first. It claims reality is defined by an absence of something, an absence of universals and particulars. What could that possibly mean? The concept is samanya-vishesha-abhava. Yeah, I know, it's a bit of a mouthful, but the idea itself is so powerful. It's saying that things in the universe don't have secret, built-in identity tags. An object is defined only by its properties, its mass, its charge, its spin, and that's it. There's no hidden thisness or thatness that makes one fundamental thing different from another identical one. Okay, lock that idea in your head. No hidden labels, no secret serial numbers on the atoms, because now we're going to fast forward 2,000 years to the totally bizarre world of quantum mechanics, where this ancient philosophical rule seems to be a fundamental law of the entire universe. So, let's just do a quick thought experiment. Imagine we've got 2 electrons, these tiny fundamental particles that are the building blocks of pretty much everything. But think about it. Really think. We know every single electron has the exact same mass and the exact same charge. So if we ignore their position for a second, what intrinsic quality is left to tell them apart? What makes one of them A and the other one B?
And the answer from quantum mechanics is it's mind-blowing. The answer is absolutely nothing. They aren't just similar, they are perfectly, fundamentally 100% identical. There is no hidden label, no secret serial number that makes electron A different from electron B. They are truly, profoundly indistinguishable. And this brings us to the most incredible parallel of all. On the left, you have the ancient Vaisheshika principle, an absence of particulars, meaning no hidden identity tags. And on the right, you have the cornerstone of quantum physics, the principle of indistinguishable particles. And the physical consequence of this is wild. It means you could swap any two electrons in the universe, and reality wouldn't even blink. Nothing would change. Why? Because there was no unique thisness to begin with.
Okay, let's just take a breath. So, what do we make of all this? We have these two shockingly similar conclusions about the very fabric of reality, reached through completely different paths, one through pure logic, and the other through math and modern experiments. So let's just quickly recap what we've uncovered here. We saw how this ancient idea of action-ness, Karmatva, is basically the philosophical version of physical momentum. It's a property of an object in motion, not some extra stuff. And then we went even deeper, finding out that the rejection of hidden, particular labels is the very same idea behind quantum indistinguishability. It just goes to show you, the big questions about what reality is, they're truly timeless.
And for me, this is the part that's just so cool. It suggests that it doesn't matter if you're using the tools of philosophy and pure reason 2,000 years ago, or the tools of mathematics and giant particle accelerators today. The human mind, when it really pushes to understand the world, can end up arriving at the same deep truths about how reality is structured. So I guess the question I want to leave you with is this. If a 2,000-year-old text can echo something as complex as quantum mechanics, what other ancient wisdom from cultures all across the globe is just sitting out there, waiting for us to rediscover it through the lens of modern science? Something to think about.